All right, here's our video today. Phoenix A versus Ton 618. Forgot to put that in. Let me put that in there. Ton 618. Get my pen ready here. Ton 618. And we actually should call this the Battle of the Quasars because Phoenix A and Ton 618 are actually quasars. But every quasar is a black hole. But not every black hole is a quasar. So remember that. Every quasar is a black hole, but not every black hole is a quasar. So what's a quasar? That's our question right now. And if we write down quasar, it's a quasi. Astronomers find ways of getting cool names, right? Quasi means almost, because they actually didn't know what quasars were. They thought they were something like stars. So they say quasi, and then they say the Latin for star, stellar. Quasi-stellar radio source. But now we know that quasars are just black holes that are feeding. That's what they are. So this quasi-stellar radio source, quasar. That's how they got the idea of a quasar. Now, Phoenix A and Ton 618 are they're the biggest quasars out there. And so a quasar basically is just a black hole, because black holes are the engine that's feeding the quasar itself. And the quasar, to be a quasar, you're gorging on huge, just huge, a huge amount of gas. It's like pigging out at a stellar buffet, all you can eat stellar buffet, stuffing their face at the dinner table with some delicious dust and hydrogen gas, right? That's what stellars are doing. Well, quasars that is. So here's an artist's rendition of a black hole. And to be a quasar, let me get my pen ready here. So to be a quasar, the only thing missing is this relativistic jet stream. And it moves out. If I get my pen's not working today. There we go. It just moves out, streams out on both sides. You don't see the other side, but it streams out light years in distance. And that's just blasted out radiation. So this is the relativistic, going on a sideways today, disk, jet. It's a relativistic jet stream. Jet stream. Right there, let's cross that out. And again, it's shooting out on both sides, this jet. Now, over here in the black hole, this is the event horizon. So I'll put an arrow right here. This line right here is the event horizon. And of course, if anything crosses that event horizon, nothing escapes. Nothing will escape the event horizon. Light can't escape the event horizon. But this stuff right here, this is the photon, not proton, photon, which is just light. This is the photon sphere. And it basically is just making hot plasma photons. Very hot. And the accretion disk is what surrounds the photon sphere. So over here, we'll call it, and let's change the color, a different color. Maybe we'll use green, see if that works. There we go. This is the accretion disk. So like I said, for a black hole to be a quasar, it needs to be shooting out this radiation. You need to have this relativistic jet stream coming from both ends. What happens at the accretion disk is you get this superheated gas. This is the gas that it's gouging on, or gorging on, right? This is the hydrogen, helium, and dust, and it's very hot, very, very hot. They call it the superheated gas disk. And what happens is then this gas disk, which is producing X-rays, shoots out into space for millions of light years that we can see. So if a black hole is not doing this, if a black hole is not pigging out, if a black hole isn't eating, and we're talking about eating a tremendous amount of gas, then it's just a inactive quasar, which are just regular black holes. So going back to our battle of the black holes or the battle of the quasars, so we have Phoenix A, and there's some debate on the size of Phoenix A. So we'll just write Phoenix A over here. Fix that H. So we have Phoenix A, and they think, and there's some debate, that Phoenix A is about 366 billion miles around its event horizon. So if you think this event horizon here, going around here, they're putting Phoenix A at 366 billion miles. That's an incredible amount of mileage. Think about this. Think about going from Earth to Pluto 10 times. That's the circumference, the boundary, the event horizon of Phoenix A. Whereas Ton 618, which was the champion for many years, and you'll probably still see it as listed as the biggest black hole, but Ton 618, the event horizon circumference is 121 billion. But both of them are still quasars as far as we know, and they're still growing. They think that they're growing at a rate of 60 suns a day. So Ton may be smaller than Phoenix A, but some astronomers think that it's more dense. So Ton 618 could be more dense. It could be more dense. There's debates on this, because there is a debate on whether how big Phoenix A is to begin with. Now, it's important to know, you're seeing this relativistic jet stream. They're escaping the black hole's gravity before they hit the event horizon, because once that plasma, once those X-rays get caught in the event horizon, then there is no escape. That's very important to know that. So, by the way, as we said, Ton 618 and Phoenix A are quasars, and quasars are black holes that are just eating a lot of gas. But there are inactive black holes. So if we're just going to say inactive black holes, the winner will actually be IC1101. IC1101 is the largest black hole that is not a quasar. So here's an artist's rendition of IC1101. I'll write it over here. IC1101. I see it right there. As you can see, it has this event horizon over here, this boundary with no relativistic jet coming out of it. And again, this is an artist's rendition. You can find IC1101 in the constellation of Virgo. So it is the largest black hole that is not a quasar. And that's our video today, the Battle of the Black Holes.